So welcome to How to Do the Homework Time. On the first section it says factor completely, do not solve, because they're not equations. First rule of factoring, is there anything we can factor out of all three of these? I think so. I know we can take out a 2 and also an x. That's our greatest common factor. And when we do that, we would have x squared plus x minus 12. So there, we have the greatest common factor taken out. But we can't say we're finished unless we check to see whether this trinomial will factor further. Are there two numbers that will multiply out to negative 12 and add up to a positive 1? Some of you like to go with the x. So 1 times negative 12, and then b is a positive 1. We need two numbers that multiply out to negative 12, add up to 1. Well, 4 and 3 multiply out to 12, and they're only 1 apart. In order to add up to a positive 1, the 4 would have to be positive, the 3 would have to be negative. So we have 2x. Now because we already pulled the 2x out, we are just factoring the part inside the parentheses. And the leading coefficient inside the parentheses here is a 1. So we can go ahead and do this as x and x. And pull over our plus 4 and our minus 3. And that would be the full factorization. Number 2. We always consider, is there a common factor? Well, these are both even numbers, so now we can divide by 2. And I hope you recognize that both 56 and 14 are in the 7 times tables. So 7 will go into both of these, 2 will go into both of these. That means 14 will go into both of these. Now if you choose to do it in 2 steps, take out a 2, then take out a 7, that's fine. This would be 14 times 4 to get 56. And this is actually x squared here. There are a couple of typos on this sheet. They have been fixed. And 14 would have to be multiplied times negative 1 to make a negative 14. Okay. But now 4x squared minus 1, that's the difference of two perfect squares. So we can factor that more. We could factor that as 2x plus 1 times the quantity 2x minus 1. And that would give us the full factorization. Continuing. Now in your copy, hopefully this is a nice clear 27a cubed. Any common factor coming off both of them? Nope. So it's got two terms. Maybe it's the difference of two perfect squares. If not, maybe it's the difference of two perfect cubes. And obviously this is the cubed situation. So we could rewrite this. 27 is actually the cube of 3. So that would be the cube on 3a, subtract, and 125 is the cube on 5. So we do have a perfect cube minus a perfect cube. And we can factor that. For this, we basically have the answer already. The cube root of 27a to the third is 3a. Subtract the cube root of 125b to the third is 5b. Then we're going to go for the first term, and then the term on the right, and then we'll find the middle. So what do we multiply times 3a to create 27a to the third? Well, that would be 9a squared. And what do we multiply to get the right side here? What do we multiply times negative 5b to make negative 125b to the third? Well, it started negative, we multiplied it, it ended up negative, so this has to be a positive 25b squared. And a negative times a positive will give us the negative 125. For the middle term, you remember that's when we multiply these two together and change the sign. So these multiply out to negative 15ab. What we're going to put in here is positive 15ab. And we could try to factor that some more. But usually once we've factored the cubes this way, this trinomial term won't factor any further. On your paper, hopefully this is 12x squared. We have 4 terms. Do we have a common factor across all 4 terms? Not quite. We could do 2, except the negative 3 on the end won't work. So for the 4 terms, that's where we tried this trick of splitting them down the middle and factoring each group. So is there a common factor between 8x cubed and 12x squared? I know we can pull off a 4, and I believe also an x squared. So to get 8x cubed here, we would have to multiply by 2x. To get 12x squared here, we'd have to multiply 4x squared by a 3. Hopefully, we can produce a 2x plus 3 over here, because otherwise it won't work. And we can. If we factor off a negative 1, we will have a 2x minus 3. And now we have 2 large lumpy terms that have a common factor. They both have a factor of 2x plus 3. So we can pull out the 2x plus 3. What's left when we pull the 2x plus 3 out of the first term is a 4x squared. What's left when we pull out the 2x plus 3 out of the second term is a negative 1. And that would be the factorization. Except that this isn't finished. 2x plus 3 is pretty simple. But this is the difference of 2 perfect squares. In fact, it's the same difference that was up here in the problem right above. This will factor further as 2x plus 1 times the quantity 2x minus 1. So that's the factoring, sort of. For the rest of this page, they want us to solve the equation. Go ahead, find the roots. And they want us to do it their way. We have to do it the way they say. And on the quiz, the directions are very similar. You'll be asked to solve by a particular method. So this one, there are lots of ways to solve it. They said factor. Anything come off both of these, any common factor? Except for 1 and negative 1, I don't think so. So we got 2 terms, and this looks like the difference of 2 perfect squares. So we could factor this as 5x plus 4 times the quantity 5x minus 4. And they still multiply out to 0. And the only way they can multiply out to 0 is either 5x plus 4 equals 0 or 5x minus 4 equals 0. So 5x is going to equal negative 4, meaning x is negative 4/5, or 5x is going to equal positive 4, so x is going to equal a positive 4/5. And those would be the 2 x-intercepts. The graph would cross the x-axis at both of those x values. Square root method. Doesn't work if we have a middle term, which we don't. And the first step is to isolate the part being squared. Well, this whole parenthesis is being squared, so we have to get that by itself. I'm going to add 3 to both sides of the equation. We still don't have the squared part by itself, so I'm going to divide by 2. I'm just going to write this as a decimal this time. And now that the squared part's by itself, we can go ahead and take the square root of both sides. The square root of something squared is itself. But this is going to be both a positive and negative square root of 7.5. Both of those are possibilities to square and come out to the x plus 6. Now, x is not by itself yet, so we're going to have to subtract 6 from both sides, and they often write this first when there are radicals involved. Still gives us 2 roots, 2 places where it crosses the x-axis. You have to figure out what the decimal approximation is. For number 7, complete the square. If there was a common factor here, like say if this was an 8 on the end, I would still divide everybody by 4. It would be legal and it would make the problem much simpler. But it's not an 8, it's a 9, so for completing the square, the leading coefficient has to be a 1. If it isn't a 1, we make it a 1. But in this case, everybody is going to get divided by 4. So now we have x squared minus 3x plus, and I'm going to leave it 9/4. Then the second step is to move the constant term after the equal sign. Now some people reverse these, they move the constant term first and then divide by 4. It works. Now when I subtract the 9/4 from both sides, I am going to deliberately leave a blank. Because we are going to complete the square. We're going to turn this side of the equation into a perfect square. It's a weird little method they developed, but it does work. The idea is to take the linear coefficient, which happens to be the -3, divide it by 2. Now remember this because we are going to need that later. Take the linear coefficient divided by 2 and square it, which gives us 9/4. And that's the missing piece of perfection. If we add this 9/4 here, this side of the equation will be a perfect square. However, we just can't randomly add 9/4 on one side of the equation. We have to make it legal by adding 9/4 to both sides of the equation. So now, this side we are going to rewrite as a perfect square. Well, the square root of x squared is just x. And the square root of 9/4 is going to be whatever we multiplied to get 9/4. Sorry, I forgot to write the squared sign here. We squared -3/2. So that's what goes in here. If we take x minus 3/2 times x minus 3/2, we will get x squared minus 3x plus 9/4. This thing is a perfect square. Now on this side, these very nicely came out to 0. So now it's okay for us to take the square root of both sides. And the square root of something squared is itself. And the square root of 0 is 0 in this case. Doesn't always come out that nicely. Which means x equals 3/2. This would mean there is one x-intercept. This is a double root. The parabola will just touch the x-axis. It won't go through the x-axis. It'll just touch it at x equals 3/2. Oh, the quadratic formula. Completing the square always works. Quadratic formula always works. In fact, they did stuff completing the square to get the quadratic formula. There would not be a quadratic formula if we couldn't complete the square. With a quadratic formula, though, we won't have to divide through by -3. We can just do that a equals -3, b equals 5, c equals -2. And then these aren't x's, it's okay. N is going to equal the opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. So n should equal -5 plus or minus square root 25. Now negative times a negative times a negative is going to give us a negative, and 4 times 3 times 2 will give us a 24, all divided by -6. So that means n is going to equal -5 plus or minus 1 divided by -6. So n will have to equal either -5 plus 1 over -6, which is -4 over -6, or 2/3, or n is going to equal -5 minus 1 over -6, which is just going to give us a +1. 2 roots, graph is going to cross the x-axis at 2 spots, and we're going to move on to the next page. So the next page takes us back a little further than just last week. On this copy, I saved it before I moved the cursor somewhere else. This is not 81 or absolute value, it's just the cursor mark. So please try to ignore that. If we graph this, which it looks like they want us to, will the parabola open up or down? Well, it's a positive x squared, it's going to be opening upwards. We're going to find the vertex, which is going to be right here. So to get the vertex, first of all, we find the x-coordinate by finding the axis of symmetry, the -b over 2a. So that would be the opposite of -2 over 2 times 1. So x is 1. But that's only half of the vertex. To find the other half, we are going to have to find out what y equals when x is 1. So we got 1 squared minus 2 times 1 minus 8, which is going to come out to -9. So there's our vertex. Our axis of symmetry is the vertical line x equals +1, I'm not doing a very good job here. And our vertex is going to be 1 across and down 9. We know that's where the parabola is going to bottom out. The y-intercept, well, that's when x is 0, so we could plug zeros in for x, or most of us just know that it's the number on the end. But technically, it's a point. When x is 0, y is -8. So that would be the point 0, -8. And because this is the axis of symmetry, we know that if there's a point here on the parabola, there's going to be a point reflected over here. So the parabola is starting to take shape. X-intercepts. Well, that's when y equals 0. So that means the x squared minus 2x minus 8 equals 0. Well, that's a trinomial, and maybe it factors. We would need two numbers, 1 times -8, that multiply out to -8. B is -2. Can we come up with two numbers that multiply out to -8, add up to -2? I'm thinking 4 and 2. But one of them's got to be negative. And if they add up to a negative number, it's got to be the -4. -4 times 2 makes -8. -4 plus 2 makes -2. So this factors now that this is going to be x minus 4 times x minus 2 equals 0. So either x equals 4 or x equals, sorry, I did this wrong. This is a plus 2, -2. Technically, they are 2 points. X is 4, y is 0. X is -2, y is 0. And then we can plot them. Across 4, up 0, which is 3 spaces to the right of the axis of symmetry, across -2, up 0, which is 3 spaces to the left of the axis of symmetry. And from that information, we've got enough to sort of sketch the parabola here. Got a little bit off there. We could plot more points if we wanted to, but we've got a basic shape here. Okay, number 10. Store manager was told by the corporate office that the daily profit in dollars is related to the number of clerks, which they're calling X, that work that day, according to this equation. So this is the profit in dollars, the daily profit in dollars, does depend upon how many clerks are working. And it's a delicate balance. If you have too many clerks, they don't have enough to do and you're paying them to do nothing. If you don't have enough clerks, they can't get everything done and the customers are unhappy. And that's not good either. So you're trying to find this magic point. Well, they want the maximum. They want us to find the maximum daily profit. That's often what people stay in business for. So the maximum, you might recall, the maximum or the minimum occurs at the vertex. The turning point. Now this graph does not have a maximum. So that would be a problem. But the equation they've given us here is a -x squared. So we know that this parabola is going to open downwards because it's a negative x squared. So we will indeed have a maximum point here. We don't have to sketch the whole graph. We don't have to keep plugging numbers in till we get the highest one we can. We just have to find the vertex. On the vertex, the x value is going to be at negative b over 2a, which for this equation is going to be negative 300 over 2 times negative 25. So that'd be negative 300 over negative 50, which would be 6. Now that's just not a plain old 6. X equals 6 means hire 6 clerks, because that's what X stood for, the number of clerks. Then they want to know what's the maximum profit. If you hire 6 clerks, you should get the maximum profit. Well, that's going to be the profit value when we hire 6 clerks. So the profit, the maximum profit, should be what we get when we take negative 25 times the square on 6 plus 300 times 6 plus 890. So the maximum profit should be negative 25 times 36 plus 1800 plus 890. So the maximum profit here is going to be a negative 900 plus 1800 plus 890. Maximum profit should be, I think this is 1790. Now is that 1790 clerks? No, because P was the daily profit in dollars. So you would hire 6 clerks to make a maximum profit, maximum daily profit of $1,790. That's not a bad daily profit. And that takes us to the end of the problems. The answers are down here. If you still have questions, please contact me, and please answer the quiz carefully before you submit it.